Welcome. So what I have here is graphing y equals ax squared plus c. And what we're going to do is look at this as y equals negative x squared plus 4. And what we're going to do is we're going to graph it. We're going to determine the vertex, the line of symmetry, and the x and the y intercepts. So when looking at a graphing like this, the best way that we're going to start off with is just by graphing this by using a table of values. All right? And that's going to kind of be our introductory method. So by using a table of values, we need to understand that we're going to use x and y coordinates because we have an x and a y axis. All right? And every single point on our parabola or our graph is contained by a point that has an x and a y coordinate. So what we're going to do is we're going to create a table of values, and we're going to choose some x values and then figure out what y values are going to be and according to what x values we choose. Now, we need to make sure, though, we always choose values that are going to be to the left and to the right of the axis of symmetry. And what we've talked about so far is our axis of symmetry, when we have an equation in the form of y equals ax squared plus c, that our axis of symmetry is going to be at 0. So therefore, the x value of your axis of symmetry is going to be at 0. All right? So we know we're going to be able to find that value. Now what we're going to do is we're just going to choose values to the left and to the right. And usually a minimum is just going to be at 2 points. So let's just, let me just pick 2 points here. Let's do -1, -2, and let's do -3. Let's do 2 points. 3 points for each way, why not? 1, 2, and 3. OK, so now what we need to do is I've chosen my x values. Now to be able to figure out the y values, what I'm going to do is I'm going to plug in each one of these points, y equals -3 squared plus 4. So I'm going to plug in each one of these points into my equation to now find out what the y value is. And it's really important to make sure that, especially when we have an equation that's y equals ax plus ax squared plus c, is that we need to make sure that we follow our order of operations. That means that we're going to first square our number first, then we'll multiply it by -1, and then we will make sure we add 4 to it. All right, so make sure you guys notice how I'm using these parentheses. That's going to become very important. All right, I'm using these parentheses to make sure that I square the number inside the parentheses, then I multiply it by -1. I don't want to make sure I square that negative. Don't want to make sure I square that negative number because that's not what it represents. It's squaring the number, then you're multiplying it by a negative number. All right, so let's go and take a look at what our a is. We could say a is equal to -1 and c equals 4. And what that's going to do is that's just going to kind of help us. We're just going to kind of get an introduction of, how is a and c affecting our graph? So when we look at, so let's go and evaluate these. So -3 squared is +9. +9 times -1 is now -9. -9 plus 4 is -5. Then we have -2 squared, which is +4. +4 times -1 is now a -4. -4 plus 4 is 0. Then we go to -1. -1 squared is 1. 1 times -1 is -1. Plus 4 is now going to be a +3. At 0, we're going to have 0 squared is 0 times -1 is 0 plus 4 is 4. At 1, we have 1 squared is 1 times -1 is -1 plus 4 is now going to be 3. Again, we're back to our axis of symmetry again. And actually, just to kind of speed up this video, we know that if you're even to evaluate these are going to be exactly the same. So now let's go and plot our points. So here we have -3, -5. 1, 2, 3, -5. 1, 2, 3, 4, 5. Then we have -2, 0. We have -1, 3. 1, 2, 3. We have 0, 4. Then we have 1, 3. We have 2, 0. And we have 3, -5. All right, so you can see as my graph, as I'm going to keep on getting smaller or larger numbers, this graph, or for my x values, as I go smaller x or larger x, you can see that these numbers are just going to keep on going farther and farther down. All right, my y values are going to keep on getting, these are all negative. Wait a minute, 3, that's positive. Sorry, that's positive, that's 7. That one has to be negative. I didn't cancel those all back out. But you can see this is going to keep on getting smaller, and this one's going to keep on getting smaller. So our graph's going to keep on going farther down. That's why, hence why I'm having my 2 arrows. So we look at this, and let's go back and label our important points. So the first important point is our vertex. Remember, our vertex is the maximum or minimum point of our parabola. Well, you can see that this graph is going to continuously go in the downward direction. However, it does have a maximum point, which is going to be our vertex. And that maximum point occurs at 0, 4. Notice that our a is negative. Our graph now opens down, and our vertex is at 0, 4. Let's look at the axis of symmetry. Now, we've already kind of talked about the axis of symmetry and saying that when we started this, we chose points to the left and to the right of the axis of symmetry. But now you can see via the graph that the axis of symmetry is at when x equals 0. And that's always going to be the case when we're graphing a line that's in y equals ax squared or y equals ax squared plus c. Now, there are something that's going to be different now. And if you look at, we have x-intercepts. And what we have is two intercepts, right? This graph crosses at two different points. It crosses at -2, 0 and at 2, 0. So therefore, we're going to label those 2 points, -2, 0 and 2, 0. And then let's look at the y-intercepts. Well, there's a y-intercept. There's only one, so it's an intercept. And that occurs at the point 0, 4. So there you go, ladies and gentlemen. That is an example how to graph y equals -x squared plus 4 by using a table. Thanks.